Hey class, Mr. Moyedin here with an example of how to prove two triangles are congruent using the two-column proof method. So here we're given a picture with two triangles. We're given very limited information. We're told that the top CH is the same as the bottom NT, and we're also told those same two side lengths are parallel. So notice we have two pieces of information on the same segment. And that's it. That's all we're given. We're not given anything else, and we have to figure out, is this enough information to prove they're congruent? Since I'm not going to do the impossible here, that is enough information. The question is, how do we get there? So you start a proof always with the given. Just a natural place to start. So we're told that CH is the same as NT, and we're told that CH is parallel to NT. And those pieces of information are not questionable. They're given, so we don't have to question why they're true. They are. But that's just a pair of sides, right? The side is not enough reason to say that two triangles are the same. So there's a side, and there's a side, but that's not enough information. So we have to use our brains to figure out what else is given here. Although, well, not exactly given, but determinable. So it's always a good idea to look out for vertical angles, and indeed there are a pair right here. So I'm going to state that those two are the same, and naturally it's good to question anything that's stated without any assumption. So why are those two angles at A the same? Well, let me name them first so we're precise about their naming. We have CAH, the top angle. I'm saying that that's the same as angle NAT. So question that. Why is that true? It's not given, so we need to be able to explain it. And the reason for that is, well, these angles famously are called vertical angles. They share a vertex, and we've proven many times over that vertical angles are always the same. So they are vertical angles, therefore they're congruent. So we have a pair of sides, we have a pair of angles. Well, side angle is not a rule either, so we've gotten some progress, but not all the way there. Whenever you have parallel lines like you do here, these two are parallel, it's generally a good idea to look for, if possible, a pair of alternate interior angles. That's just a general hint for a lot of these proof problems. So I've outlined some of the shape here in blue. If I isolate just what I've drawn in blue, I have those two parallel lines, and then I have this transversal. So this angle over here and this angle over here are going to be the same size, if these lines are parallel, which given that they are. So those two angles in the original picture are here and here. And if you look at them, they appear to be the same, and we can say they are because we have a reason for that. We know that they're the same because they're alternate interior angles. So that means that in statement 3 I can say angle, let's see, angle H, that's the original one, it's kind of covered up now, is the same as or congruent to angle T. Now you might notice I called the other one CAH and the other one NAT. That's because there are multiple angles at A, whereas there's only one angle at H and at T, so I'm safe by just calling them H and T. There's no confusion as to what I'm referring to. If I say angle H, we all know where to look. So the reason that I know those two angles are the same, even though it was not provided to me, is because they are alternate interior angles. And we've proven at some point in the past that alternate interior angles are always the same, so we can use that idea in this proof. We don't have to reinvent the wheel every time. And now if you notice, we have one of our criteria met. We have two pairs of angles, the blue angles and the green angles, and a pair of sides that were given. So we have two angles and a side. The question is that ASA or is that AAS? Well, between the angles would be this right here. There's no marking there. Between the angles here, no marking there. So we have two angles and a side not in between them. So even though we have limited information, this is enough information, so it's a shortcut. That's enough right there, two angles and a side, to conclude that triangle CHA, the top shape, is the same as the bottom shape, which is triangle NTA. Even though we don't know all the side lengths, angle side is sufficient. As we saw in the computer lab, it's enough information. So there you go. There's a pretty quick triangle congruence proof. You'll notice a couple of things to help you prepare for your assessment. Prove is never a reason, so don't even think about using that one. It's just a choice there to fill in some space. You're never going to use prove as a reason in a proof. Anytime you see these two as answer choices, you know it's not going to be those because those do not always make the same shape. So it's not going to be a sufficient reason to back up a statement and a proof. All right, hope this helps.